Hello, everyone. I welcome all on our webinars. So today we will speak about dstack. We will launch a new series as AI Project Spotlight, on which we will speak about different projects, AI projects. We will speak about tools and see on real how it works from founders, from core developers. So today with us, Andrei Cheptsov. He is a founder of dstack, and he will show and talk about dstack and about ML workflows and infrastructure. Yeah. For now, I will give the microphone to Andrei.
Thanks, Dmitry, and hi everyone. Thanks for having me. Actually excited to talk about dstack and reproducible ML workflows. So that's what we're going to talk about today. And before I do that, a quick intro on my end. So I'm Andrei. I come from technical background. I used to be a software engineer for many years. Then I also worked for about 10 years at JetBrains, where I did many things and worked with different developer tools, including PyCharm. And most recently there, I've been involved in the data science tooling development. So I worked with PyCharm to bring the rework and improve their support for GPT notebooks. And that's how I was introduced to the topic of ML. And not long after, I've started to work on my own tool called dstack, which is aimed at helping people make the ML workflows more reproducible and in general, help them collaborate easier and run easier their workflows in the cloud. All right, so here's agenda. This is what we will talk about today. We'll start with the quick intro into ML workflows, what exactly we mean by that, and what kind of ML workflows are there. We'll talk about their typical challenges, pitfalls, and problems that you might face when you start working on ML workflows. And then I'll introduce you to dstack, and I'll show how it works. And if time allows, we'll have a little demo. And then if there'll be any questions, I'll be happy to answer them. So let's begin. The first thing we want to talk about is ML workflows. So what are ML workflows exactly? And it's important to fix the terminology. So we mean the same thing when we say that word. So typically, workflow is something, we use that word to refer to some group of tasks that's related to a certain goal which we want to achieve. For example, when you build software, or for example, if you test software, there is such a workflow as testing, and you can carry out that workflow within an ID. So these are different things you do in order to test your software. So in ML, there are also such workflows, and they include exploring the data, preparing the data, training models, running apps that use models, and of course, deploying models. And it is worth to mention that these workflows can be carried out in different environments. For example, you can explore data using your ID in interactive fashion, and then you can prepare data, for example, as a job that you run at batch on some cloud, for example. And of course, there might be some cases such as CI/CD, for example, when you want to run certain workflow as a part of your CI/CD pipeline. Like, for example, retrain the model on commit or on the event of creating some tag, and so on and so forth. And yeah, finally, to mention, sometimes you may want to trigger an ML workflow programmatically. Imagine you have an application and then you'd like to, for example, retrain some model based on certain event. For example, a user uploads a new data or something like that. So yeah, roughly speaking, these are, let's say, essential workflows which you can be involved in when you work on ML. So you may wonder how these ML workflows are different from the normal or the traditional development. There are a couple of things, and number one, ML workflows, unlike let's say traditional development, involves a lot of experimentation, and we'll talk why it is so important that this particular difference in their second next slide. Then ML workflows also may involve large amounts of data and also models as artifacts, which means that your workflow may either produce those things or it may depend on the things. And when you run, for example, workflows, these things must be taken care of. And finally, ML workflows require very costly hardware, which you don't always have locally, meaning you have to provision that hardware, and that's also adds this complexity in ML compared to traditional development. And so these differences actually create quite a few challenges. And challenge number one, which, well, yeah, lots of you might have heard about, is this friction between roles involved in ML workflows, and in particular, the friction between two phases, which are experimentation and productizing. So typical example is when you're working on a model and you do a lot of experimentation, you use some interactive environment, and once the work is done, you actually want to productize it. And what often happens is that when you try to then productize it, you actually have to reproduce what you've done. And if you have not tracked all those things, and if you have not refactored all your code into like modular structure that can be easily reused, it might be problematic. And quite often what happens is when there are not just different phases, experimentation and productizing, but also different teams or roles. And when one person is working on experimentation, and then once it's done, the result is passed by to the other folks who actually do productizing, more DevOps kind of people. And yeah, so for example, it's always quite problematic, especially when the result of this experimentation is either a notebook or just a plain model without the source code or the original data. So that's that friction I mean when I say friction between experimentation and productizing. Then the other let's say major issue is the poor standards for versioning data and models. Like, for example, in traditional development, we know such things as library, a package, source code repository. And when it comes to data and models, well, there are not so many things like that. And there are not so many tools that allow us to version these things, even though there are quite a few. But the problem is that there are not that there are no tools, but the problem is that there are no common approaches to that. And often these approaches are fragmented across different teams, and every team is using something custom. And of course, when teams want to collaborate, problems appears and actually increase that friction we've just talked about. And finally, the third issue related to ML workflows is the poor standards for workflow orchestration. And what I mean by that is when I say workflow orchestration, I mean several things, and probably the main thing there is hardware provisioning. So in order to run your workflow, you actually have to provision their infrastructure. And if we, for example, look at the existing infrastructure provisioning tools, we will see that, well, for building software, we have CI/CD solutions, but they do not really fit when it comes to experimentation or other kind of ML workflows. And finally, when we, for example, think of things like Terraform or Kubernetes, which are very often used for deploying software, they again don't really fit for ML workflows because, well, unlike deployment, ML workflows are temporary by nature, and you cannot simply use these things easily for ML. And many people try to do that, and as a result, they often have problems. So having said that, this is where dstack steps in. And originally, I decided to build dstack in order to solve some of these challenges. And dstack basically is the result of that work. And what dstack is, it is basically a lightweight utility. It is a command line tool, which you can install locally through some different package managers. The easiest probably would be to install it via pip, most familiar for ML folks. And what this tool does is, first, it allows you to define your ML workflows as code, like, for example, in a form of YAML file, where you define, okay, so what are the workflows, what are the dependencies between them, what are the output artifacts, what are the particular code that needs to be run. I'll show you an example of such a file, and then the utility allows you to run these workflows from the command line. So pretty much like other tools, like, let's say, Docker, Terraform, Kubernetes, except that, well, dstack is not as complex as, let's say, Kubernetes or Terraform, but the concept is pretty similar. You define workflows as code, and then you use the CLI in order to run it. And when you do that, dstack provisions that workflows directly in the cloud. So you don't really need some other things. Like, for example, with Kubernetes, you need Kubernetes. So dstack works pretty similar to Terraform in that sense. You only thing you need to have locally is your cloud credentials. And as long as you have them, you use the CLI, you use the dstack run command, and it provisions that workflows and then takes care of everything from hardware to artifacts and dependencies. And of course, it provides the built-in containers. So you don't really have to think, okay, so what Docker image I need to use, or do I have to install the CUDA drivers, or what version and all, whether I need to install Python myself and all. And yeah, we'll take a look at how it works more precisely. And that's what is already available with dstack. And of course, we have a lot of things which are not implemented yet, but in our plan. And one of the things we're actually working now on is helping teams to collaborate. For example, it is already possible to reuse the artifacts of workflows across projects within a team. But what is missing, for example, right now is that inability to define, for example, certain team permissions, and also manage team codes, for example, which team can use what amount of computer resources and all. So let's move on and take a closer look. Right. Here we go. In order to use dstack, you have to install the CLI, and this is done by the pip command, pip install command, and then you have to run that command called dstack config. And before you do that, you make sure that your cloud credentials are present locally on your machine. And when you run that command, it just asks you, okay, so what AWS region you want to run your compute in, and then what S3 bucket you want to store the state. And this one is important because if you want to work as a team and collaborate together, it is important to configure the same S3 bucket for everyone. And once it's done, then you basically can see the state, the common state between different users, and then reuse the artifacts, as I've said. Yeah, finally, you can also configure some other settings, such as like whether you have to use custom VPC, sorry, or not. But that's basically it. So just one command. You don't need to install anything. You just need to have cloud credentials, and you need to select an S3 bucket. And once you've done that, you can start writing your workflows. And here's how it is done. The file where you have to define your workflows is called workflows.yaml, and you have to put it inside your project repository. So basically inside this .dstack folder. And yeah, here on the screenshot, you can see the structure of the YAML file. What is noteworthy here is, yeah, you have a list of workflows. And for each workflow, you, for example, see that it has a provider, and I'll talk in more detail about what it is and how it works. But basically, you have to choose a provider for every workflow, and the default and the standard provider is Bash, which allows you to run Bash commands. And here in this commands field in YAML file, you actually can provide your Bash commands you want to run with this workflow. You can do pretty much anything that Bash typically allows you to do. And important that these commands are running inside the built-in container provided by dstack, regardless of what cloud it's running. And you can rely that this Bash actually has Conda pre-installed, it has all the Qt drivers pre-installed, and it can even, you can even activate Conda environments as you would do interactively when you work with Bash, if you want. So it's interactive mode. Then you can specify the artifacts, output artifacts for each workflow. And what that means is dstack has this information, and then when the workflow is finished, it takes care of storing this artifact in the storage that you've configured at the previous step. And then you can either access these artifacts, or you can assign a tag to it and then refer from other workflows, like we do here. For example, the train workflow, you see this depths property where it refers to the output artifacts of the first workflow. So basically here we chain into two workflows through the tag. You can also reference other workflow directly, but tag allows you to refer to a particular revision of that output artifact. And when the workflow starts, it makes sure that it pre-downloads all the artifacts from the dependencies. Yeah, finally, you can look at this resources property, where you can configure any requirements to resources. For example, you can say, okay, this workflow has to use interruptible instances. Interruptible is another way to say spot instances, which are cheaper if you want to save costs, for example. And then you can also say, okay, I need some specific type of GPU, and specify the count, the number of these GPUs. And that is it. When you run your workflow, it will provision exactly the required resources. And this is how it's done today. So in order to run something, you use that dstack run command, where you pass the name of the workflow, and immediately it will print the unique name of the run and its status, and then within a minute, it will provision the required hardware and will start running your workflow, and you'll interactively see the output as you would see as if you run run that locally. Right. Maybe the last thing before I switch to their demo is there are multiple providers, and this one is Bash, which we seen in the slide, but there are also other providers which, for example, allow you to attach interactive dev environment. For example, you can attach a VS Code ID running within this workflow, or Jupyter Notebook running in this workflow. And when you run them, you see the link in the output logs, you click it, and then it opens this interactive environment. And you can use that as long as the workflow is running. So having said that, let me switch to PyCharm. Here we go. Changing the screen I'm showing. Right. So now I think you should see my PyCharm, and what we have here is a Python project called dstack-examples. I've opened it in my PyCharm, and what I have here is, all right, the manist folder with 2 Python files, download.py and trend.py. Yeah, it tells me that I need to set up the environment. Let's do that. Yeah, it just says that these packages are not installed, but we won't need that for the demo. What we'll need is several things. We'll need the terminal, and you can see it here. And you typically install dstack using this command, pip install dstack -u, meaning that if you already have some version of dstack running installed on your machine, then you can upgrade it just to make sure that you have the latest version. Right, so it's configured. So now if you run that command, you'll see that basically that it tells you how it works. If you're not sure, if you're just getting started, make sure that to run that dstack config, which we talked about. And when you run that, it asks you about the profile you want to use, the region, and then the bucket. And finally, the EC2 subnet. And that is it. Once it's configured, you can start working with their CLI. And here you see other different commands. Like the main command is, of course, dstack run. Then we have a command dstack pc, which shows you the currently running workflows or recently finished workflows. For example, if I use it now, it will show me that I don't have anything just yet. What else? We have logs, stop, artifacts, tags, secrets, RM, stands for remove, and others. All right. Then we have here workloads.yaml file. That's very similar to what we've seen in the slides. We have 2 workloads here, download and train. And in order to run any of these workloads, you basically run dstack run, for example, download. And then you can override some things which you've defined here. So for example, you can override, you can add dependencies if you want, you can override the resources. For example, you can say, okay, I need to use the interruptible instance. But what is also possible is that, for example, if instead of running it in the cloud, you may want to run it locally, which is also possible, for example, for testing purposes. And this is what we'll try to do. So for example, so let's see, I've already, for example, we can check the tags which we have here. We already have a manist data tag, but for the purpose of that presentation, let's let's not use that and instead create a new one. For example, we run the download workflow, and then immediately we say that we want to assign a tag to it, needs data. Now let's actually run it locally, just to save time a bit. All right. When you run it locally, it will download the runner if it is not in the cache, and then it will use that runner to run the workflow locally as if it would do in the cloud. So now you see that once it's stored, you see the interactive logs coming in, and this is from that pip install command. And then it will run this download.py file. And then once it's done, it will save the output files inside the folder data as artifacts. Right. So for example, we can use PS to see what's going on. So for example, here, it tells that, yeah, that workflow is actually done, but it's still uploading the output artifacts. That's what happens when you finish running certain workflow. Make sure that output artifacts are stored in the storage. Yeah, now it's basically already finished. And for example, if you use the artifacts command, artifact list command, and then pass this run name there, it will show the content of these output artifacts. And you can, if you want, you can download them using the download command, or you can assign a tag to it, which we've done. So here you can see this minist data. This is exactly the tag, which we assign it to that artifacts. And we use the command dstack tags. Yeah, we'll see that with 1 minute ago, we've created that minist tag. And now we can actually run the train workflow, which uses this minist data to train a model. Let's just do that. Run the train. And then, yeah, we can actually overwrite and say, okay, so for example, I want to use some number of GPUs or very particular GPU. You want to overwrite this interruptible property and tell dstack to use interruptible instances if you want to save money on training, or as we've done that just now, you can run it locally. And let's do that. And this command will basically work pretty same way as the download workflow. So it will just start there. So the workflow locally. And while we do that, what we also can do is probably checking how other providers work. Let me, for a second, switch my screen to the documentation. All right. Here we go. I need my Chrome browser. Right, now you can see the documentation. This is where you get if you open dstack.ai. And what is interesting here is, of course, when you just want to try it, you can start here. So there's a dedicated page with a lot of examples on how to use dstack, from very simple hello world to how to use it with Python and with Conda, how to create custom environments at all, how to override resources and specify GPU at all, then also how to manage artifacts, dependencies, specify environment variables for your workflows. There is also such a thing as apps. For example, workflows dstack allows workflows to expose ports. For example, you can say my application needs one port, and you basically tell that through the ports property, and then dstack will provide you that port through the environment variable, and you can use it in your workflow. For example, this is how you can run Grady or Streamlit or Fast API or some other applications through dstack. And then you decide where to run it, in the cloud or locally. And then, of course, you have these secrets. For example, if you want to configure some kind of a token and make sure that dstack stores it in the encrypted storage, then you can use this dstack secrets command, which has add and delete commands. And for example, this is how you can provide your weight and biases token or Hugging Face token if you want to use them from your workflows. And finally, the thing why I originally opened that page is dev environments, is to give an example of what that is. So basically, when you define your workflow, you can specify the provider. And in the demo, we've seen that we specified Bash as our provider. But now here you can see the example where, for example, you specify code instead of Bash. And all their available providers are listed here on the provider reference page. So we have Bash here, code, lab, notebook, and Docker. And we may add others soon because, well, they are provided through an extensible extension points, meaning that anyone can create custom providers and extend the standard list with their own providers. So what code provider does, as I said, it attaches VS Code developer environments to your running workload. So for example, here's how it works. Let's say we use this example, and let me now switch to my IDE from the browser. Right, I hope you can see that now. And we've copied that code here. Now, for example, we can, for the, why not? We can actually run, let's see if we have available spot resources with GPU. So what we'll do is run IDE. Basically, we're on the IDE workflow, and it takes some time for dstack to provision that hardware. And let's see if spot instance is available right now, just to save some money and not create the on-demand instance. Right, basically it tells that, insufficient capacity, but that's expected. So let's not use spot instances right now, and instead, use the on-demand instances.
Which type of GPU instances you run? Because you're not write which type. So
yes, that's a very good question. By default, dstack tries to find a compatible instance which matches the criteria, and if you haven't specified the GPU name, it uses the most cheap one. And in that case, it's going to be probably the cheapest Tesla GPU that AWS has. It's what is it, K80?
Yeah. But I can define what type of
yes
GPU I want. Okay.
Basically you can say I need to V100 or A100. And then if you want, you can also specify the count property, but by default it treats it as one.
Okay.
So typically
it's understand what type of GPU, and then check what is the type of instance in the cloud.
Yes, and it uses the pool from their region which you've configured. Just to make sure, just to maybe tell people that listen to us that if you want to use interruptible instances with AWS or some GPU instances, first thing you have to do is to make sure that there's a service quota approved by the team. Sometimes it's very irritating that before you can actually use GPU or spot instances, you in particular region, you have to contact the support team in AWS to approve that request. But well, once it's approved, then no problems, and you can use as many as you want, as long as it's less than it's configured for that particular region. Yeah, and some of the users of dstack actually ask us for allowing you to configure the limits, and also at a certain point show the usage for different users, just to be able to see, okay, so who is using what, how much, and then allow to enforce some policies around.
Yeah, I have one question about, is it possible to see that we really run in AWS?
Yeah, basically we will see that right now. Please.
As I understand, it's about can we show the AWS console that it's really run on AWS?
Yes. That depends. Showing Cloud Console is might be sensitive, but let's see what we can do. So here just now you see that instance URL, and if you click that, let's switch the screen to the browser. And we see that we've opened that URL, and what we have here is exactly our repository already checked. And then we can open a terminal. And then we have this exact version of Python, which we actually had locally. We have conda here, and the SMI command showing that, yeah, exactly, we have Tesla K80. And yeah, so that I'm just showing you how you can use the code provider in order to interactively work with your workflow. So you still have your workflow defined, and you may use certain dependencies which you want to use. And then you can even configure some output artifacts. You can have specify their hardware requirements, and then use your interactive dev environment such as VS Code, work with your project, and then turn it down once you don't need that. But yeah, believe me that it's actually running in my AWS account, and if you install dstack yourself then and run that that workflow from the tutorial, you also see it actually in your console, which is even better. Right. So let me on first thing is interrupt that instance, just to make sure that we don't pay for the GPU, even though it's not that expensive because we use the cheapest one. It will be even better if it's a spot one, but that depends on the spot availability. So now, yeah, now we close that one and get back to their documentation. And each provider, as we see here, has different properties which you configure. Like, for example, before run, you can run certain commands in order to prepare your workflow. You can, for example, activate specific conda environments, and even write it to your bash profile file configuration. And when you start, for example, VS Code, open it in your browser, it will automatically activate your conda environment which you need. You can also override the version of Python requirements if you want to install it automatically. Then, of course, you can specify artifacts, resources, working dir, and yeah, other things. So what we have here is also lab. Lab is very similar to code, except that it starts not the VS Code, but Jupyter Lab. But it works pretty much the same way. You also, when you run your workflow, you see the URL, you click the URL, and then you see the Jupyter Lab. Notebook is just a single notebook server. And yeah, finally, sometimes it may be that you need a very, very specific Docker image. And this is something that you cannot really do without using your own image. Then you can actually use the Docker provider and specify your own Docker image. The rest is pretty similar to as Bash provider. You also have the list of commands and artifacts, resources, and so on and so forth. So that's mostly it about providers. But as you see here, we have also the CLI reference page, which is also useful when you want to learn what commands are there, what parameters they support, because there's a lot of things, right? The most interesting is, of course, the run, because, well, this is what you use most of the time. You run your workflow, you can run it in the detached mode, and then you won't see there immediately the output artifacts, but you'll be able to see them using the dstack logs command. That is needed, for example, when you want to trigger your workflow, for example, from, let's say, GitHub Actions or GitLab CI/CD. You can trigger certain workflows as a part of your CI/CD pipeline. And well, if you don't want your CI/CD pipeline to wait until the workflow finishes, then you may want to run it in the detached mode. But that's just one of the use cases. Then it is also worth to mention that with args, you can override their properties which you have in your YAML file, such as resources, like whether you want to use interruptible instances, when you want to run it locally, and so on and so forth. Yeah, that's basically it, I think. That's what I wanted to show you. And yeah, happy to see if there's any questions. And even if there are no questions, I would encourage everyone to take a look at the GitHub repo, where we have a lot of links, and then also some brief tutorial. And of course, we have a dedicated documentation website where you can find a lot of information how to install, use dstack, and different scenarios. Right. Yeah. Having said that, Dmitry, let's check if we have any questions. Let me also see.
I have several questions.
Yep.
I will start maybe. So first, as I understand, dstack for now support only AWS, any other cloud providers.
That is correct. At the moment, it's only AWS. And we do consider support Azure and GCP as well. And yeah, anyone is actually even able to help us with that, simply because dstack is 100% is open source. Everything is in GitHub. And if you want to also help us implementing, for example, GCP or Azure, ping us on Slack and we'll talk, and so we can collaborate. But other than that, we of course plan to support it pretty soonish. It's just that AWS was the majority, like the choice of majority among the people we've actually been spoken to. But absolutely, it would be great to have it for other clouds as well pretty soon.
Yeah, and do you have some plans, for example, support not only cloud, but local clusters, servers? Because sometimes you have some local servers on which you train the model, but in case if the local server is full for the training, you start to use the clouds. So do you have some plans for to support local servers?
Right, that's a good one. And I think absolutely it should be supported. And I would even say that at certain points we had this public. We had an option to install a self-hosted runner on your machine, and then and then this machine would be added to their pool of machines, and then when somebody runs the workload, then it gets assigned to one of these available runners. And at a certain point, we just decided to focus on the cloud simply because, well, there is a lot of friction when it comes to using the cloud, the reproducible way, not to click through the AWS console and create some notebook and then go through that thing.
Yeah.
But it's totally important, I think, to have your collocated server support as well, because I know a lot of teams actually use them. So for us, it's just a matter of their priority. And well, if you have a lot of service and you'd like to use dstack, yeah, ping us and we see what we can do. So like there are things we can do, for example, provide you the experimental version of self-hosted runner so you can test it and then make sure that it's running all right on your end. And also, yeah, just discuss the actual requirements. I think self-hosted runners is important for quite a few use cases. For example, computer vision is one of these use cases where when you need to use your service simply because the data sets are very heavy, and downloading them, even though they
if it's not in the cloud and it's local, it's better to train it's local.
Yes, I think that that is a very important case. And if you are interested in having that feature and using dstack, ping us, and maybe we'll implement that even sooner.
Okay, we have the questions about warming. If, for example, we run our training and the GPU is full, RAM full, or CPU, is it possible to see some logs of and warming that something is full on the training server side?
Yeah, let me know if I got it right. So the question is whether it is possible to see the stats about the actual utilization of the GPU and other hardware resources, right?
I think, yeah, it's something like that.
If not, please correct us. But if that was the question, it is not provided out of the box from dstack, but there are a number of ways of actually tracking these things. And yeah, probably the simplest one is using waiting bases because it's built in. And all you need to do is just configure the secret with your token, and then initialize the repo project name, and then you'll see all workflows in your waiting bases, which is also convenient not just for tracking the hardware metrics, but also for tracking the experiment trackers. Of course, if you want to have that, if you want to out of the box solution, but there are other ways too. And if that doesn't cover, then come to the Slack channel and we'll talk, and I'll tell about the other possibilities there.
I have more questions.
That's good.
Yeah. You show that when we train the model, the dependencies will install it before the training. I don't want every time to install all packages which need my model for the training. Is it possible to write, for example, the ID of EMI of image which will be used for training instance, or I need to use Docker on this case only?
Right. I think that's a good question, and it has some depth. And maybe it's worth starting with saying that when you specified some AMI, it's still downloaded. Just so you know, it's just the question is how exactly it's handled, the download part, because in the end it's about the collocation, how quick is the download process. And yeah, when you specify your specific AMI with some packages pre-installed, then it's just faster. And I totally get that concern about, okay, so how do I ensure that it's faster? And I think, yeah, at this very specific point, we have our own AMI, but we do not allow you to configure certain dependency to be pre-installed. We just don't allow that for now because, well, the download still is taking place on the AWS side and typically is faster, and download dependency is not that long compared to their typical workflow, right? So for example, if you just want to print the version of Python, it would make sense to install some 25 gigabytes Conda environments just to do that. But if we are talking about running a heavy training process, then in itself this takes a couple of hours, then download will take, I don't know, a couple of minutes at max. But please.
Yeah, in some cases it's good, but sometimes you want to, for example, prepare some specific configuration to or do some specific optimization of the packages for more quicker trainings, for example, or in my side, I have some cases when we optimize the infrastructure.
That is possible, by the way. If I can just comment on that quickly, it is possible. So, for example, at least a lot of let's say cases are covered by Conda, and dstack has built-in Conda Forge and allows you to save your Conda environments as output artifacts. So for example, some of the users that use dstack do is they install a custom Conda environment, which can be super complicated and involving installing a lot of native code, and then saving that folder as an artifact, and then simply using that dependency through a tag. And then anytime their workflow starts, for example, which depend on that tag, dstack just downloads the artifacts, which is faster, a lot faster than installing these packages, right? Because in the end, yeah, mounting files is a lot faster.
Okay, good. I have one question.
Sure, go ahead.
Okay, I train it as a model. Now I want to deploy it. Can I do this using dstack? For example, in SageMaker inference.
Yeah. So at this moment of time, dstack is not about deploying, and deploying is actually possible. You just need to run a certain bash command that will deploy your model into SageMaker. So no problems with that. It is absolutely possible to deploy to SageMaker, as it is possible to deploy to any other services. So yeah, it doesn't replace SageMaker in a way, and that's not what we wanted to do in the first place anyway. So the idea is that dstack helps you automate your workflows, but you have a choice of what exactly you do inside that workflows, and whether you want to deploy it to SageMaker, then it's your choice. But that's an interesting topic to discuss, because dstack, for example, allows you to run applications as workflows. But what we don't actually have at this moment is the deployment scenario supported. So for example, there's no autoscaler, which would autoscale your infrastructure depending on the load, downscale if it's not used, and upscale if it's if there's a lot of traffic. So that particular feature is not implemented yet, but we don't rule this out if we actually add that too. And then you would basically stick to dstack for everything, including deployment. But given this high variety of ways you may want to deploy your stuff, yeah, so far basically it's your call, and you do that inside the workflow if you want to deploy it, but it is going to be deployed to some other place.
So if I understand correctly, so I can run, for example, my model using dstack, and it will be available till some of the state of workflow is running. Similar like lab or
yes. Yeah,
okay.
you can run
Yeah,
workflows for debugging purposes with dstack,
oh,
but when it's
interesting.
production, then it's probably better to within dstack to build that, for example, package like Omnix, for example, or some other package, or even use some open source tools. Like, for example, there are lots of them like COG or MLAM or others. Or just build your Flask application, which uses the model stored as an artifact within the registry of dstack.
Yeah, good. Thank you. Have more questions on Slada now?
Right. If yeah, somebody missed that presentation and gonna watch it online on YouTube as a recording, yeah, on GitHub and or the website, documentation website, you'll find a link to the Slack channel, and there you can ask these questions, and I'll be very happy to answer them later.
We have also 2 questions from our Zoom user, but yeah, I don't understand why users come to the Zoom and not want to ask by microphone and write in the chat. But okay. So one question about does the stack has capability of stop CPU or GPU when my training or training completely done?
Right.
Testing, sorry. Training or testing.
Yes, it basically does it. As far as I understood, it asks whether it is possible to, yeah, tear down their infrastructure once the workload is finished, right? Please correct if it's right.
But if I understand, if the training or testing is done, its infrastructure will be shut down.
Yes. I actually see the comment here telling that it was correct. So yes, it's done automatically. Once your workload is finished, dstack will deprovision the hardware. It is done automatically. You just need to exit the process. So for example, if it's a running, if it's a Python program, then once it reaches certain condition, like accuracy or some external condition, then it just exits. And once it exits, then dstack notice that and mark that workload is done and deprovision the hardware automatically, so you don't have to do anything. Yeah, hope that answers.
Okay, good. So I think if will be more questions, join to the dstack Slack channel or to our Data Phoenix channel. We will discuss and answer for your questions. So today, thanks for Andrei for this good presentation and for this tool which he created and driving to growing. I hope these tools find more customers and users, and it's open source, it's good, so all can connect and help Andrei develop and do this tool more better. So thank you for this presentation.
Thank you, Dmitry, for inviting. That's a great chance for us to show what we do and show it to more people, basically.